Hello and welcome to the Academic Integrity Research Summary, presented by the Panda Analytic Group at the University of Arkansas. You may wonder why we have decided to give our team such a strange name. Simply put, the name reflects our team's heritage and will surely stick out in the mind of anyone who happens to hear it. We are proud to attend a university that strives to create a culture of honesty and personal and professional responsibility amongst its students, faculty, and staff. The academic initiatives give our degree more credibility. Just so there aren't any surprises along the way, we've drawn up a roadmap of the topics we're going to discuss. Part A will include some background information about the project. Part B will be the summary statistics, so preliminary stats about what was found in the research to get you familiar with what we're talking about. There will also be information about the RAISE intervention, aimed at deterring students from committing academic dishonesty. Part C will get into the nitty-gritty of the research, regression modeling. This can be used to both explain past behavior and make predictions on future trends. Notice, I said make predictions and not predict the future. There's always going to be some uncertainty involved, but having a model always takes some of that uncertainty away. And finally, in Part D, we will be talking about a decision tree model. It's been proven that a combination of multiple models will perform better than just one. So taking that advice to heart, we've compared multiple models here. This survey is designed to examine students' academic integrity attitudes and behaviors, and also to assess what factors may influence their judgment of what is considered appropriate or inappropriate. A set of questions were created to test our students' knowledge of academic integrity, their attitudes toward academic integrity, their awareness of the University of Arkansas academic integrity policy, past experiences of academic cheating, and many other issues. So what are we trying to find out? Well, with the data from the survey, the UA Vice Provost wants to know what the characteristics are of those students participating in the survey. 2 rounds of surveys were actually carried out. After the first round, students were asked to take an online training session. Then they were given the second survey. The Vice Provost would like to know whether the training sessions made a difference for academic integrity understanding. Using SAS Enterprise Guide and SAS Enterprise Minor, we were able to generate a regression model to understand which factors affected students' intentions of cheating, and a decision tree to predict future students' behavior of committing academic integrity violations. To get a general overview of the dataset, we ran summary statistics tests on a majority of the variables. For example, take the variables PBC home/copy and SN home/copy. They have means of around 4 on a scale of 1 to 7. It shows that students are almost indifferent towards the subjective norms and resources on cheating. There are groupings such as gender, college, HINT target, which is a student's likeliness to cheat on homework, and CINT target, which is a student's likeliness to plagiarize. No difference was found between females and males when put against the variables indicating knowledge of academic integrity and variables indicating their attitude towards academic integrity. In the college variable, grad had the smallest representation but got the highest mean score compared to the other 3 colleges. HINT target equals 0, which is a student without intention of cheating, had slightly higher mean scores for knowledge of academic integrity and rate of academic awareness when compared to students without intention of cheating. Variables related to the theory of planned behavior model were used as a method to predict students' behavioral intentions on sharing homework and plagiarism. Significant differences between HINT target equals 0 and HINT target equals 1 were found for variables ATT home and MO home. Slight differences were found in PBC home, and no obvious differences were found in SN home and past home. Similar results were found for plagiarism. After the first survey, students were asked to take an awareness program before they took the next one. Scores were recorded for both surveys, which leads us to the next step in our strategy, paired t-tests. The mean of differences on pre-post knowledge of academic integrity is negative 0.0459, which is not a big difference. The p-value is shown to be negligible, and at a 95% confidence level, we are able to reject the null hypothesis. that there was no change in knowledge of academic integrity due to the intervention. Also, we can see that the mean difference between intervals are all on the negative side of the axis and do not cross zero. Thus, there is a statistically significant difference between pre- and post-knowledge of academic integrity. This means that the RAISE intervention improves students' knowledge of academic integrity. The mean of differences on pre-post attitude towards academic integrity is 0.4733. The p-value was once again shown to be negligible, and at a 95% confidence level, we are able to reject the null hypothesis. Moreover, we can see that the mean differences between the intervals are all on the positive side of the axis and do not cross zero. Therefore, there is a statistically significant difference between pre- and post attitudes towards academic integrity. The RAISE intervention clearly makes a difference on students' attitudes towards academic integrity. All of this is, of course, good news. For data pre-processing, the main task was to treat missing values and eliminate outliers. Our data had very few missing values, less than 1% to be precise. Plus, most variables were on a 7-point scale, so it was not necessary to perform filters. This allows us to move on to our next step, variable selection. When choosing variables, we first use insights from previous characteristic analysis, which provide us with a big influence in our current variable selection. We then use correlation to check covariance and prevent multicollinearity. After that, we have candidate variables, which are in the tables shown. The next step is selecting a model. We leave primary model selection work to ISYS Enterprise Guide. Full model and 3 assessment methods are used, and the results are then compared. These are shown in the tables to the right. We use 3 main criterions when choosing the best model: fit statistics, concordant, discordant, and ROC curve. Both models favor stepwise methods. Take a minute to observe the results shown here in the graphs. The HINT model has a misclassification rate of 11.5%. Moral obligation and attitude are the most powerful predictors. 3 cultural variables are statistically and practically significant. Subjective norms and IC are not included in the model. The CINT has similar results with slightly different details. MO and ATT are still the most powerful predictors. PBC is excluded, and moreover, MF becomes insignificant for CINT prediction. Because a decision tree has a built-in mechanism to deal with missing values and outliers, no extra imputation and filtering are executed. A data partition node is used to divide the data into training and validation groups on a ratio of 60:40. 5 decision tree nodes are deployed using different assessment methods provided to us. All the results are then compared by a model comparison node. The main criterion of choosing a better tree is the misclassification rate. For the HINT model, 3 trees share the same misclassification rate, and they are able to correctly predict 90.1% of the total sample. For the CINT model, the misclassification rate is 17.1%. This slide shows one of the tree models as an example. The tree consists of 4 variables: attitude towards copying, moral obligations of copying, uncertainty avoidance, and awareness of academic integrity. It is possible to achieve 82.9% accuracy in predicting the target variable with this model. Note the circled subtree. Although the model is not doing a good job identifying these samples, in all practicality we can regard these 117 students as people with a high intention to plagiarize. These are students we want to provide with necessary training courses and relevant coaching programs as a precautionary measure. Hopefully, with the intervention, we can substantially reduce dishonesty in the university classroom. Not only this, but we would like students to change their attitudes towards academic integrity. As students, we don't want to come before an academic integrity violation board just as much as you don't want to see us there. While we cannot remove all uncertainty from predicting who has the higher intention to cheat, we certainly can pinpoint more accurately with the help of prediction models. This particular research showed that decision trees offer better results in comparison to regression models. And that just about wraps it up. This has been a presentation by Panda Analytics, and we would like to thank you sincerely for watching. For more information about the university's initiative, be sure to visit provost.uark.edu/academic integrity.